I'm really excited because this is a topic I'm super passionate about. I have my good friend, everyone's my good friend tonight, Dr. Otto Doppelsberger, who's going to be talking about specifically client side versus server side Blazor, which is something I'm super passionate about. So I'm going to let you take it away, get your computer up, and here you go.
Thank you, James. Yeah, welcome. We're going to talk about client-side versus server-side Blazor development today. We're going to see what the differences are, what scenarios you should choose one over the other, and we're going to see a live demo where we have the same app deployed once as a client-side WebAssembly app and once as a server-side app, and we'll see how it behaves differently since this app has a few routines in it that, well, behave differently on each deployment. So first, we're going to go really quick over it, what the differences are. Then we're going to compare them and discuss when to choose one platform over the other. And then we're going to look at the demo that I prepared that will show these theoretical aspects we're going to discuss in practice. And at the end, we're going to have a Q&A. So most of you should already know what Microsoft Blazor is. Some of you might be new to it and just get started with it with the release of .NET 5. But in essence, we now have an interactive web UI where all we need to use to program is C#. We can create reusable components, just like some of us are used to do already with other frameworks. We can now do that with just using C#, HTML, and CSS, and we're no longer dependent on JavaScript, for instance. We can run directly in the browser using WebAssembly, and yeah, that is actual real .NET that we run there. And we can use our existing .NET libraries for our projects to do that. Optional, we can also run on the server, but we can reuse the same code. So if you have an application created that's a client-side Blazor app, and you later find out, hey, this would actually run better if it was hosted server-side, it's not that big of a deal to change it over and deploy it as a server-side app because the code doesn't change, and I'll show that as well. You'll see that my application contains exactly the same code on both projects. And sometimes we still need to use JavaScript, however. Blazor is, in comparison to other frameworks, still fairly new. It's not been around that long, and there is just certain things that don't exist yet in Blazor, in the Blazor environment. And sometimes we're required to still go and use certain JavaScript libraries or certain JavaScript controls or something, and we can do that still with JavaScript interrupt from a Blazor application. When we talk about client-side Blazor, the cool thing is it's a single-page application framework. Just like most of you who have done web development probably know other SVA frameworks for JavaScript. With WebAssembly, however, we have a little different approach how this whole application then runs. When it runs client-side, we have what we call WebAssembly. WebAssembly is shortcut WASM. That's what I'm going to use in my presentation. It's optimized bytecode format, and when I say optimized, I mean optimized in both size and execution. So when your code is compiled into WebAssembly code, it is already very, very, very optimized and runs as fast as it possibly can the way it's developed. It has full browser functionality using the JavaScript interrupt. So WSM actually runs in what is a browser JavaScript sandbox. So you still have access to all the API that a browser regular has access to in Blazor. You still can access your video, you still can access pictures, you still can access files and so on. Whatever your browser allows you to do, you can do in Blazor through JavaScript interrupts. The way it works is your C# code and your Razor files will be compiled into .NET assemblies, and then the assemblies and the .NET runtime will be downloaded if you have a Microsoft Blazor WebAssembly project, a client-side project. Now, this, I have exclamation mark here because this could be one of the downsides, and we'll get to that later. Because, well, as I said here, every time you run a client-side app, it has to be downloaded, right? So that might be quite a significant thing. However, it can be cached, so it's not every time somebody browses to a web app, it needs to be downloaded. That can be cached by the browser, so that can alleviate some of that load that needs to be downloaded.
Hey, Otto, can you just hit that little hide button right there on that little StreamYard pop-up? See the little tiny little hide button on top of your, it's on top of your slides. I don't know if you see it. Right down there on the bottom. Do you see a little pop-up?
No, I do not see a pop-up.
Oh, interesting. We see it. Okay, it's okay. I think probably just how you're presenting. No worries.
Okay. Then with Microsoft Blazor server side, it's a little bit easier to visualize what it looks like and how it works. Because when you have a server-side Blazor hosted application, it runs on, as the name implies, on the server. And all your interaction with the application go through a Signal R connection that has been established to that server. And using that Signal R connection to the server, also all the interrupt will be handled. The pros and cons for doing client-side Blazor apps. Well, on the pro side, .NET can run directly in the browser. That is the first time you can do full stack C# development for web apps. So that's probably one of the biggest advantages. For me personally, the third bullet point here is one of the biggest advantages as well. It works offline. So you can deploy your client-side Blazor app as a PWA, as a progressive web app. And that means once you have it open once and it's downloaded, you no longer have to have an active internet connection. So you can create mobile apps, for instance, that you then install on your mobile phone, and you can run them whenever you want, and you no longer need an active internet connection to interact with them. Theoretically, client-side WebAssembly apps are faster than JavaScript. And that is a big theoretical here because it really depends on the circumstances. It really depends on what you're doing. It really depends on how you implement it. Plus, it depends on the life cycle of where we are in terms of how long Blazor has been around. With .NET 5 now being released, there have been a lot of performance critical aspects being improved. So your app that, if you had performance problems before, probably will run a lot better and smoother now under .NET 5. But it's theoretical, right? There's still a lot of things that just run faster in JavaScript. But we'll see that in my demo as well. There's certain things that just run quicker, one or the other. So we'll see that in my demo as well. The cons of client side is, well, as I said before, the whole runtime needs to be downloaded. So if the first time you browse to a web app that's hosted client side, the download is significant, and it is obviously a lot more than if you had a comparable web app that is hosted in server side, Blazor, for instance. You don't have support for thin clients if the browser doesn't support WebAssembly. Obviously, if you have a browser, for instance, even older desktop browsers like Internet Explorer that don't support WebAssembly, you will not be able to even use the web application. So if you, for instance, have a smart fridge at home and you want to write an app for it that automatically reorders milk if you run low, it probably won't run on your smart fridge's browser if it is a client-side hosted Blazor app. Debugging options limited. That's also one of the things that it's not necessarily limited. So maybe it's the right thing to say is a little more complicated. If you have a server-side Blazor app, debugging works right off the box. You don't have to do anything. You can set breakpoints and hit them immediately in your Razor pages. If you do client-side development, you will have to do a few things, have to edit some of the launch settings in the JSON file. So there's a few things you have to do. You can do it. It's now, it wasn't initially when it was released, but now there have been improvement made where you can do debugging on client side as well. It's just one or two extra hurdles to jump over. On server side, well, it's fully compatible with any .NET library or tool that you have been using before. You might have some libraries you were using on other .NET projects, on other ASP.NET projects, or on a WPF app, for instance. If you have any libraries or DLLs you want to use that are not that are working under .NET, well, you can use them here. You have the same syntax as client-side Blazor. So like I mentioned before, if you have a server-side app or a client-side app and you want to switch it over to one or the other, you can do that at any time. The big thing here is the third one where it says heavy lifting done on the server. We'll see that in my demo, that if you have something that executes and takes a long time or requires a lot of processing power to execute, at some point you will get to the limitations that your browser has, and it's a better idea to do it on a server, for instance. The download size is significantly smaller, and it works with all thin clients, and both of these points have to do with the fact that if you have a server-side Blazor app, all you really download is HTML and maybe some JavaScript to the browser to display it. Even thin clients, they can display HTML. So you're not limited to who and what browser can use your application. So it's really universally applicable. The cons for having a server-side app is network latency. You have to have a constant internet connection. So therefore, your app also uses more bandwidth. So that, of course, if you have a situation where you might encounter internet interruptions or heavier latency issues, then server-side might not be the best idea for you. .NET is required on the server. Obviously, if the app runs on the server, .NET must be installed on the server. If that's a problem, then that definitely is a con. And the other thing is you might run into a limit of simultaneous signal R connections that can be established to your server. Now that obviously depends on the scalability of your app. If you host the app in Microsoft Azure, for instance, every hosting model that you have has a different limitation of how many continuous or parallel connections it can serve up through Signal R to users. And that can go from the lowest tier with only 20 all the way up to 100 million. So that should be enough for most applications to serve 100 million people at the same time through the scaling that can be done in Azure. But obviously, that also increases the cost of the hosting. Now with that, let's look at the demo, and we'll look at two apps. I'm going to open them in the beginning side by side, just so you can see. It's not really necessary to see what the code here is. I'm going to make one of them bigger so you can have a better look. I just want you to see on the left side is my client side WebAssembly app. On the right side is my server-side hosted app. This is the exact same application. It has the exact same code. And what it is it's the starter app that you get with Microsoft Blazor. And I added a new page to it where we perform something that is or can be considered heavy lifting, so to say, and we'll see how each individual one of these deployments perform in it. So I'm going to make this site bigger so we can take a better look at it. And at the very bottom, I have a function that finds a prime number, the nth prime number of a given input. So this is something that I decided to put in here because I thought, well, let's put something in here that takes quite a little bit of time to execute. And so we have to wait for the result to come back. So I added this function to find the nth prime number. In my app, I'm looking for the 100,000th prime number. And the app is deployed, and you can, I don't know how well it will show through stream. There might be some latency on the stream as well. But I have deployed the app, and you can browse it yourself at the same time if you want. If you go to .NET Blazor wasm.azurewebsites.net, this is the deployed version of the WebAssembly app. And if you go to .NET Blazor server.azurewebsites.net, that is the exact same app, but this is the server version. So it's the same app deployed twice, and it's live, so you can go there anytime, right now, later, tomorrow. I'm not going to take it down. So you can try this out yourself. Now, what happens is I have it implemented that if you select a superhero from this list, and so this list is pre-loaded with a few of the superheroes, you select one, and it will calculate that superhero's strength or power. And that power just so happens to be that prime number that I have a function for. So whatever superhero you select, the 100,000th prime number is that superhero's power level, so to say. So let's say, for instance, we pick Superman here from the client-side deployed Blazor app, and you will see I clicked it, and now my app doesn't respond, right? So now my app, it takes about 6, 7, maybe 8 seconds for my app to respond again, but it runs client-side. The way this is implemented, the way my routine works, it's not run in async. It's just a regular function that just takes a while to execute, but my browser doesn't respond right now, right? I cannot click anything, nothing else works. I have to wait for it to execute, and now it's done. And now I can see, all right, Superman is selected, and here is Superman's power that has been calculated to be the 100,000th prime number. Now, if I do the exact same thing, but as a server-side Blazor app, right? Again, I can pick a superhero here. Let's pick Batman, for instance, and it will do the exact same thing. It will select Batman. It will calculate Batman's power to be the exact same number. But first of all, my app is responsive. You can see I can hover over. I could click other stuff. Secondly, it runs a lot faster. It executed in just a few seconds compared to, it was actually more than 6, more like 10 seconds on the client-side Blazor app. Here it was maybe 3 or 4 seconds, and the result was there. I can click here and click Superman and click back to Batman, and you can see it remains responsive, right? In the background, yeah, it has to talk to the server, and you can see that with some latency, it changed to Superman and then back to Batman. Because it just took a while also on the server to execute, but as soon as it had the result, it sent it back to my client here and displayed the result here. All in the meantime, my entire app stayed responsive and did not lock up or stop responding. Now, you could argue, sure, you could implement that function to run in async, and then you won't have that problem client-side. Yeah, you could. But then sometimes you run into problems where you don't have access to that code, right? You might want to use a library that does these calculations for you. You don't have access to the code. That is not implemented to run async. It just runs just like a regular routine from A to Z. And you'll have to wait, right? And if you have no other way other to use this routine or this library the way it comes, then you have that problem. Now, the other thing is, let's go back to my client-side app here. And let's look at another thing I implemented, and that is creating squares and working with UI elements. So if you click this button to create squares, I'm creating 1,000 little squares, and they display on the screen. And I'm using just standard SVGs here. And if I move my mouse, they are supposed to follow my mouse cursor. Now, this is the client-side deployed Blazor app, and you can probably see that it does not follow my cursor. It just ends up at the end of my cursor where I place it, and it's not a smooth transitioning from the starting point of my position of the cursor to the end point. So these little squares, these 1,000 squares, they just start following, but they don't show the intermediate steps and just end up of wherever I end up moving my cursor to. So it's not a very smooth transition. It takes about half a second for my squares to follow my cursor. Now, if I did that same thing, looks like I've lost connection. Well, this is a server app, right? If you for whatever reason lose connection, you reload it, but there we're back. If I do the same thing on my server app, right, where I have constant connection to it, I create my 1,000 little squares and I move my cursor. Now you can see that there is intermediate steps, right? My cursor, I move it here and my squares, they follow it with multiple steps in between. It does not just go from point A to Z, but it follows every single step in between. However, you can see that it takes more than half a second to end up at the final position. So you can tell that, yeah, there is more steps in between to follow my cursor, but the time spent from the beginning to the end of the animation on the server-side app is longer than in the client-side version of the exact same thing. Here it takes half a second, here it takes 1.5, almost 2 seconds for my squares to end up at the position my mouse cursor ends up in. And that shows you the difference on performance. Something that is heavy in calculation, just takes a long time to execute, is probably better served up as a server-side application where you can do that on a server. You don't overload the client with all that calculations. If you have to do something with UI, something where the UI has to be responsive, where the UI has to respond to you as a user, to your mouse interaction, to mouse movements, then that's probably a better idea to do it client-side, because here it reacts a lot faster. Now, yes, it does not show the intermediate steps, but that is because I implemented this as a one-liner with no performance in mind whatsoever. I should probably enter or perform some performance enhancement where I limit, for instance, the event triggers, that I don't trigger an event every single pixel that I move, right? If I move from here to here, that would be, what is that, 400 pixels at least, plus some up and down. So that would be 600 events just moving from the mouse cursor from here to there. That is probably not the ideal scenario. So I would have to limit this, curl some of these events together, make it a smooth transition, and I would probably be better served doing that as a client-side application if I have to interact with the UI in that way. So that opens the door for apps like games, for instance, or any CAD applications, or stuff like video editing or picture editing software, right? Where you don't want to do it as a server-side app because you would have to upload the video to the server first before you can do some editing on it. If you have the video on the client, right, on your mobile phone, for instance, and you run this as a client-side app, you can probably get a lot of performance out of this simply by having that in mind when you develop the code for all this picture or video manipulation. All right, looks like we're nearing the end of my time slot here. If you go and take a look at the article that we published in Code Magazine, there is an overview over everything that's new in .NET 5 that has been introduced with .NET 5 and has to do with Blazor. From all the .NET Core libraries to virtualization, CSS isolation, and so on. You can all read that in the article in the new Code Focus magazine. And if you have any questions, let's hear it, or you can always send me an email as well. I'd be happy to answer any questions if I can.
Awesome. All right. Well, we actually do have a few questions. So I'm going to go ahead and bring on my board really quick here because we have another minute or so. Here we go. From Sunny asks, is the experience with Angular helpful to learn and adopt Blazor?
It is not necessarily in the development itself, but in the concept. Because if you go up in a route where you develop individual modules and individual components, and you are used to doing that in an Angular app, then yes, then it's very helpful to just understand the architecture. But obviously, from a programming standpoint, in Angular, you would program in JavaScript or TypeScript versus here in C# for the most part. I mean, sometimes you have to do some JavaScript interrupt for very few things, but for the most part, it's C#. So yeah, it can help you, but not necessarily in the programming itself.
Gotcha. Yeah, I found whenever I just needed to write JavaScript, I just grabbed a NuGet package and someone did it for me already. One more really quick one here. From DeVito, can you mix web server-side and client-side apps together, like in a single page?
In a single page, no. In an application that spans over multiple pages, yes. Yeah, of course you can. I mean, if it redirects you to a different page, then obviously that is not a problem. However, I would really think about the necessity of doing so because maintaining it and deploying it could be, or depends on the size of the application, but become a nightmare at some point. I would really weigh the options of pros and cons, whether you want to do a server-side or a client-side app. And I mean, it's never too late to switch over, right? You can always switch it over later and completely change it from server to client-side or from client to server-side within the half an hour or less, because it's the same code, right? The only thing that's different is the setup of the environment or the setup of the architecture of your app. So I would probably not recommend doing it.
Gotcha. Yeah. Pick out one, see what works well for you. Well, Otto, thank you so much for the presentation. I really appreciate it.
Thank you too, James.
Have a good one. Cheers.
Have a good one too.